Volume of a pyramid. What do you got for me? 28. Volume of a pyramid, Tyler.
1/3.
Okay, hey. Yesterday, BH. Today, now we put a third with it. And this gets me so fired up that kids forget the 1/3 when it's on the darn formula sheet. Look at it. All right, don't try to be a hero. Look at the formula sheet and write down the correct formula. Yesterday, we talked what capital B meant, and that was capital B. 28 again, Tyler. Area of the base. Yep. Now, I want to make sure we're very clear on what H is here. Because a week ago today, I stood up on those desks and did the whole Mission Impossible act and said, hey, there's two heights in a pyramid, slant height and altitude, aka Mission Impossible. Let's be very clear. This H represents the altitude. All right, this is the altitude. If you want to write Mission Impossible height to help you out, that's fine. That's the altitude, not the slant height. All right. All right, let's do it. Find the volume of this pyramid. You guys know how this is going to go. I warned you yesterday. One question on a figure, and that's it. We go right into word problems. Again, let's not forget 1/3 there. Let's not forget 1/3. Just like I did yesterday, even though I probably don't need to, but I'll do the work for capital B over here. How do you find the area of that base? Hook me up. 24. How do I find the area of that base? 10 times 10. So the area of that base is 100. What's the 13 pointing to in that pyramid? What's the 13 pointing to? 6. I've used that term before.
What?
I've used that term diagonal height before. What have we used? The height on one of the triangular faces. We abbreviate it with an L as well. And I was wondering why call it L when it starts with S? I've spotted you the first two letters. Ends in ant. There we go. Slant height. That's the slant height, right? I don't want to use that because that's not the altitude. I draw in the altitude. All right, let's remember our pyramid days last week. I forms a right triangle. I'm trying to find the altitude. This height, I know I'm going to have to do Pythagorean theorem, but I'm missing the other leg. How did we find the other leg? What was the little rule? How do you find the other leg? 6 again. Here we go. Redemption time. That's how I'm going to find H.
Okay.
But I'm missing the other leg. I can't do Pythag yet. So how did we find this other little leg here last week in pyramid? There you go. So I'm going to plug in 5. Go ahead, Pythag it is, and let me know what you get with H here in a second. So you do your little Pythagorean theorem, and H, the height comes out to be 10? 12. Good. I plugged 12 in for H, and I'm on my way. 400 cubic inches. Again, from yesterday, if you are writing units, make sure they're cube, please. All right, next up. All right, we're done with the figures. Let's hop right into a word problem. This pyramid has a square base. The perimeter of it is 36. The height is 15. What's the volume? All right, same formula, right? I'm going to plug in 15 right away for the height. Also, again, let's make this clear because a couple people have already asked me in this class and last class. If I want slant height, I will write the word slant with the word height. All right, if it just says height, you can assume, yes, that's the height of the pyramid or the height of anything. If I want slant height, I'll write the word slant in. I'm not plugging in 36, though. Absolutely not. That's not the area of the base. So how can I get from perimeter to the base? Give me a side length, then. What's the side of this square base? If the perimeter is 36 and it's a square. 16. 9. Yep, 36 by 4. I get 9. So then that makes the area of the base what now? 11? 81, 9 times 9. So there's 81 per capital B. We okay on how we got there? I know it's easy when we do it together, and then on your own, it's like, So what are we looking there? 405 cubic inches. All right. We're good there. All right, ready to go to Egypt? Little trip. I'm going Giza. Not too sure if that's how you pronounce it. That's what I'm rolling with. Anybody wants to know, there you go. Okay, there it's an actual legit pyramid. That thing is mammoth. Look at that thing. The thing is huge. Just because I like doing it and telling you guys this story, I'm going to keep on doing it, even though it's probably going to, you guys probably would just like me to continue on with the notes, but don't care. Look at that volume, almost 2.6 million meters. Visually, what is that? Say you have a cube, all right, little wooden cube, whatever. Has anybody, you've seen a meter stick before? You know, if I put it on the ground here, that thing's going to go up pretty high. All right. So if you have a wooden cube that's 1 meter by 1 meter by 1 meter, pretty big cube. All right, it's going to come up pretty high too. Pretty big cube. There's 2.6 million of those that can fit into there. All right. 2.6 million of those big cubes fit in there. That's what that means. All right. Good talk. I'm satisfied. I got to tell that story. What's one? I don't care about the base area. I want to know one side of that base. So we go to Egypt. What's one side of that square base? 2,592,276 is equal to, did you forget the 1/3 already? Come on, you're better than that. Equal to, I don't know what the area of the base is, but I do know what the height is, 146.5. You get me to capital B, and then I'll ask somebody, how do I go from the area to a side? What's your next move up here to get B by itself? We can get rid of that for today. 20, how do I get your first step to get B by itself?
I multiplied the volume by 3.
You can multiply both sides by 3. You can divide both sides by 146.5, or you can multiply 1/3 in 146.5 and divide that out. 3 different methods. But either method you do there, I know that's not my final answer. So that's why you're going to see me writing this now. 53,084.15017. There it is. That's not my final answer, so that's why I write out all the decimal numbers after the decimal. All right, now I need you to get into the honors level. If the area, and it's a square, so don't divide by 4. It's not perimeter. If I have that area, how can I go to a side now? Square, length times width, right? All the sides are equal. So how do I go from the area to a side? 18? Take the square root. Yep, there you go. Take the square root of your area. And let me know what's it to the nearest meter. What is one side? This is ridiculous. 22, one side of that square.
230.
That's one big square. 230 meter sticks laid right on top of each other there, side by side, whatever, right in front. A big square. All right, all good with pyramid. Go back to your reference sheet. Hook me up. Cone. 10, cone.
1/3 higher squared height.
That's pretty detailed. It's still BH, 1/3 BH. Except for B, it's a circle. So Zach said, pi r squared for B. Oh yeah, it's a circle. Times height. It's still 1/3 BH. All right, just like we usually do. Let's do a figure, make sure we got it down, where all the parts are. It's not really a 2-part, it's just 2 different ways I want you to leave your answer. First way is in terms of pi, and then nearest tenth at the end. All right, help me out. I got 1/3 pi, no r. No r there. No radius length. How are you going to find the radius? 24? Pythag, go ahead. Be careful, 17 is the hypotenuse there when you do Pythag. 17 is the hypotenuse. 4, when you get it, radius length. What do we got?
8.
8, thank you. 8 squared. Out of the 15 and 17, what are you plugging in for height? Out of those two values, 27. 15. 17 is your slant height. Remember, I wanted this answer in terms of pi, so don't touch the button on your calculator yet. Leave it pi. What do you got in terms of pi? 6? Yep, thank you. And then part B just says, all right, I want to make sure, because we got a Regents coming up a month from tomorrow, by the date anyway, can we round appropriately? Nearest 10th, 320 pi to the nearest 10th. 21?
1005.3.
There you go, Dan. Any ravioli today?
No,
No? Okay. Disappointing. Anything exciting?
I had a turkey sandwich.
Okay. Mayonnaise?
Yep.
Any other, like lettuce or
Yeah,
tomato?
lettuce. No tomatoes,
No? Anything else I'm missing?
no. Well, bread.
True, very true. White, wheat?
White.
White, okay. Are you the person that takes the crust off?
No.
Yeah, good man. Keep it on and eat it. Yeah, it's fine. All right, taking it off. All right, number 2. One whole, or did you split it? Like how was it cut if it was cut?
It was split.
How? Diagonally?
No, just like vertically.
Vertically?
Yeah.
Okay, old school. All right. All right, good. All right, volume of the cone, 96 pi. Height 8. What's the diameter? I'm still going to ask this, but most of us know it. When I write this out, there is no diameter in the formula. But what will lead me to the diameter if I knew it? 7? Radius, so we're solving for radius now. 96 pi over here. 1/3 pi, r stays r, and I'll plug in the height of 8. We talked last unit about this. Hey, if I got pi's on both sides, you can cancel it out. Only if it's on both sides. Just don't see a pi and cancel it automatically. It's got to be on both the right and the left. And then what are you doing from here? I'd like to hear algebraically how you're going to get r by itself. What's your next move? 27. Next move? All right, yep, sure. We can divide by 8. We can multiply by 3. Whatever floats your boat. Let's see if I divide by 8. Jeez. 1. Oh, that's a multiplication table. 12 equals 1/3 r squared. That's pretty bold. 36 now equals r squared. Multiply both sides by 3. R equals 6. All right, answer the question, though, for me. 20 diameter?
12.
12. Thanks. Even the units. Whew. All right, now we get serious, these last two. Let's see. I threw in the cylinder from yesterday to keep you fresh on your toes. We could read all through everything yet. Here's the bottom line. I have a cone. I'm going to fill the cone with water, pour it in the cylinder. How many cups can I pour in so the cylinder does not overflow? Okay, that's what I'm looking for. Bottom line. How many of those cones can I fill up, pour in the cylinder so the cylinder doesn't overflow? There's no mention of volume here at all. Oh, and there's no mention of cubic units at all. That tell me it's a volume problem. So a month from now, when we're taking the Regents, how am I going to know this is a volume problem? Because that could be surface area, it could be. Whew. How am I going to know this is going to be volume for me? What's up, Nick?
In the problem, it says full cones, which would imply area.
Where am I putting the water? Inside the cone and inside the cylinder, right? Anything's inside, we're doing volume. Absolutely. Good. All right, so volume of cone and cylinder. Here we go. Let's calculate the volumes of both, and then I'm going to need somebody. What do I do with the two? All right, I'll do the cone first. 1/3. Don't forget about the 1/3 again. Pi r squared times the height. All right, 3 is the radius, but I am not plugging 5 in because that's called my slant height. I actually need the altitude. So everyone's doing Pythagorean theorem. Ooh. Hey, Tyler, 28. When you have the height, let me know. 4, yep. And just like the problem a few problems ago, notice I'm not going to round this volume because it's not my answer. 37.6991184. There's the volume of the cone. All right, let's do cylinder from yesterday. No 1/3 here, just pi r squared height. Everything's given to me. Beautiful. 4 squared times 7. I actually have to do that. Pi times 16 times 7. Here you go. 351. All right, I got both volumes. How can you determine the number of cups I'll need? And then we'll have to talk about that as well. Which way do I go, up or down on that number? How do I figure out the number of cups? So I pour 1 cone in. That takes up about 37.6991184 of the cylinder. How can I figure out here? What are we rolling with? 2? How do I figure out the number of cups?
You take the amount of volume in the cylinder and divide by the amount of volume.
Okay. And I do that on my calculator. And I get a number slightly bigger than what's circled there. Everyone sees that number on their calculator. What is it? 9.3 repeating? All right, what do I do now? Do I go 9 or do I go 10 here? Go back to the directions. Here's what you know what to do. Out overflowing. I don't want this thing to overflow. If I pick one over the other, it's going to overflow. So how many cups am I going to need now? 10? 9 cups. Ooh, so close, so close. I know everybody is waiting. Good. And the final problem. I'm going hands off. When you and your group have it, let me know. I'll come over and check it. Great problem right here. This is where I need you to be at. And hey, I know today was pyramid and cylinder, cone and pyramid day. I don't have either of those in that diagram. See what you got. Everybody in the group is in agreement of the final answer. Everybody. Before you call me over. If you're watching at home, here's all the work and the answer. Try that again. There you go. Okay.